Hi, I'm Laura, and let's follow this electron's journey through the rapid cycling synchrotron. First, let's find out more about the electron-ion collider and the rapid cycling synchrotron. The electron-ion collider is a new accelerator that's currently being designed to study the atomic structure. We'll collide electrons and ions in order to do so. The rapid cycling synchrotron will be responsible for accelerating electrons up to high energies to collide with the ions to hopefully discover more about the structure of atoms, and more specifically the strong force in gluons. Gluons are the carriers of the strong force, acting like a glue that holds the atoms together. Let's get back to our friends, the electron and the ion. It's believed that when protons, neutrons, and nuclei travel at very fast speeds, close to the speed of light, they'll appear as dense walls of gluons that will appear to linger longer and multiply. If we collide them at very fast speeds, we could get the chance to take dynamic snapshots of these gluons using detectors in the EIC and learn more about atomic structure. But we need more than just one electron and one ion. We want to collide an electron beam and an ion beam. This is where electron bunches come in, or groups of electrons that will travel through the synchrotron together. We want our particles to stay in radio frequency buckets, or regions of stability for the particles. The particles are essentially trapped in the bucket. The RF bucket looks like a smiley face, so this means that the electrons will be happy and stable in their bucket. Now that we have our electron bunch, how are we going to accelerate the electrons up to the high energies we need? This is where our radio frequency cavity comes in. RF cavities generate electric fields, which will provide a force on the electrons. We want this force to act in the same direction that the electrons are traveling in. This will give the electrons a push forward, accelerating them. But our electron bunches are too small right now and won't be strong enough or intense enough to collide with the ions. So let's merge bunches to get a bigger bunch. In order to do this, we need two RF cavities that are out of phase with one another. Being out of phase means that they'll be at different points in their cycle of producing electric fields. This is an animation I created of two bunches merging to become one bunch. Their RF cavities are pi out of phase with one another, just like the previous drawing of the two sine curves. Also, the first RF cavity slowly turns off as the second RF cavity slowly turns on. This allows us to slowly move the two bunches so that they come closer together, because we're shifting the RF buckets of these two bunches so that they come and overlap. This makes one big RF bucket that will trap the particles of both bunches so that they become one big bunch. This bunch will continue to accelerate until it reaches the final desired energy. Then it will be ready to collide with the ion beam. I hope you had just as much fun learning about an electron's journey through the rapid cycling synchrotron as our electron bunch did.